हां हां बरोबर आहे तसं करतो.
कुठे आहे तू मेसेज कुठे आहे?
यूट्यूबवर आहे ना ते याच्यावरच आहे डेस्कटॉपवर इथं.
नाही मी एडिट करून त्या दिवशीच पाठवलेलं आहे सरांना. आहे ना?
हां नाही नाही काल आम्ही कन्वर्ट केला ना रन होत नव्हता तो पुन्हा अजून डबल ओपनच होत नव्हतं ते.
आडवा ओपन होतो नाही ते.
नाही नाही वरचा आहे
सर काल ओपन झालं होतं ना सर,
नाही नाही हे नाही वरचा आहे
फक्त आवाज येत नव्हता.
वरचा याचा आहे हे त्याला सुरुवातीलाच रन करू. सारखी सर आलं
नाही ना
ओपन विथ त्याला ओपन विथ VLC करावं लागेल.
वरता आली आहे सर.
हां याच चला रन करून
म्यूट होतो मी.
नोट करू का सर?
Mute. Hello. Okay. Yeah. Hello. Good morning, everyone. Dear participants, can I audible to everyone?
Yes.
Okay. Okay, madam. Yeah. So, dear participants, good morning and welcome on second day in 2 days online workshop on application of solar power in irrigation, organized by Department of Physics, Vinayakrao Mahavidyalaya, Vaijapur, District Aurangabad, Maharashtra. So today's resource person, Miss Madhu Chandrika Chattopadhyay, deliver her lecture on solar energy in irrigation technology. So before to that, there is a special message from CDC, Vinayakrao Mahavidyalaya, Vaijapur. I will just play for only 1 minute. Yeah, sir. Yeah. Yeah. Is there something wrong, sir? This one is actually not working. Yeah, play here. Play. Ha. Ha.
Hello.
Yes. Yeah. 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 Thank you for all participants being the part of this online workshop. Right now, we are facing the COVID situation, particularly in Marathwada and Aurangabad. There is about 450 like that each day patients. However, uh, we have to take ourselves, and I request ma'am Madhu Chandrika to deliver his good talk uh, on solar energy, uh, particularly on irrigation technology, its various parameters. So welcome, ma'am, and we
Yeah.
continue. Yeah. Yes.
Yeah. So good morning to all again. We will be meeting again now today. So today I'll be talking about the solar water pump for irrigation, but in terms of technology. So let me share the screen now.
Yeah. Just ma'am, I have shared multiple participants. Yeah.
Okay.
Yeah. Just you type. No
Okay.
problem.
Madam,
Madhu, ha. या इथून केलं ऑलरेडी केलेलं आहे मी फर्स्ट हां ओके ओके चलो ओके ओके सर थँक्यू येस सर
So, uh, just- first I start with the advantages, we call it as benefits of solar water pump. Why we should learn the technology of solar water pump. Uh, if we know the advantages and challenges with this, then only we can go ahead with this project. Yesterday we have seen few challenges like climatic parameters affects every solar module technology, any technology in future or in past, whatever the technologies has come, all as it is nature dependent. So climatic parameters like your temperature, wind speed, humidity, and even turbidity affects the generation of the solar module. So some advantages of solar water pump here is given in the list. First one is no dependence on erratic grid power and saving on expensive diesel. So as we know, in most of the solar agriculture fields are in the outskirts of our cities, and the grid connection to them is either sometimes it is high voltages and low voltages, so it is very irregular for them. In that case, there is a chance of I could hear some noises. If you could mute everybody, that's
yeah
better.
yeah all participants are request please mute all audios because that require much more bandwidth and goes to formation of resonance noise
Yeah.
yeah
So the fluctuation in the voltages in the grid damages the pump, whether in AC pump or DC pump. So this is a main problem for going for the solar water pump. And next one is, as in the absence of electricity or in the grid, farmers are forced to use the diesel to run the pumps. Again, that emits carbon dioxide emission. That is one issue. And other issues are now the price of diesel has gone up to around 100 rupees. So this is one advantage why we had to go for solar water pump. Second one is higher yield due to crop irrigation during daytime when crop gets all the necessary ingredients, sunlight and water. So the continuous supply of water from the water pump makes the crops to grow properly, and as the sunlight is also available along with the water. Water output across all seasons to cultivate multiple crops every year. So it's not like that the farmer has to wait for only the rainy season to grow the crops because water availability is better in that season. But if you install a solar water pump, you can grow multiple crops in the whole year. And as it is only one time investment, and the fuel for whole year is free. The fuel here is your sunlight. One time investment and zero running cost, of course, for many years to come. Easy for farmer to cultivate the land during daytime rather than nighttime when the grid is erratic. As we know, the most of the farming has been done, cultivation is done in the morning time only, and your solar water pump, as we discussed yesterday's session, that even though it is not connected to grid, we don't use battery for this because for the cultivation the water is required only during the morning times. If we need it in the night times, then the battery is required. But as I know that farmer doesn't work in the night times in the land. Drip and sprinkler systems can be connected with solar system to further improve the crop yield. As a sprinkler system can be also used, so that it spreads the water properly to the total area. Solar system needs to no maintenance except regular cleaning of modules, easy to operate. So not only for solar water pump, any solar system doesn't need much maintenance, only cleaning of solar modules, not with any water or any chemical, but just clean the module with dry cloth. If you use it for your home or any, this is a maintenance of the solar module. If it is rainy season, then 20 millimeter rainfall is a minimum required to clean the solar modules. Or else you just take a dry cloth and just clean it, the module, once in a week. If it's a big power plant, they clean it once in a month. contribution and reduction of carbon emission, contributing to reduction of pollution. Of course, that's true. If you are using the grid electricity, conventional electricity that is coming by burning coal, so in that way the emissions are done. Or if the farmer is running the pump using the diesel, again you are generating the carbon dioxide emissions. So this is one advantage applicable for any renewable energy, that contribution to reduction of carbon emissions. So these are the advantages why we should go for the solar water pump. Now come to the technology. So once we understand why we need to use this system, then if we are convinced with that advantage, then only we can go ahead. Anything, whether buying anything, even buying a motorbike also, we go through, we compare and we see if convinced, then we buy. In this case also, first you know the advantages, then go for the technology. So solar water pumps, as you can see in the figure, it has solar modules, solar array. Array, as we discussed yesterday, array means some modules are connected in series and also in parallel. So solar modules, it has AC DC solar pump, and that pump is of two types, centrifugal or submersible pump, depending on the depth of water. If you are using river or lake, we use centrifugal pump. If you are using the water which is deep, below 14 meter or below that, then we use submersible pump. It's like borehole. For borehole, we use submersible pump. Next, support structure and tracking mechanism. This we call it as mounting structure. Mounting structure is used for not only for solar water pump, any solar module we install on a mounting structure. Okay, that mounting structure is required because it holds the solar modules fast, and if you install directly the if you install solar module directly on the ground, then there is a chance of dust accumulation on the module very easily. And secondly, the flow of air is required. If the module gets hot, then the generation falls. Okay, so for that reason, the flow of air, for that you need a certain space in the down portion of the module that the air flows and automatically makes the module cool for some time. So next one is tracking mechanism. The tracking mechanism is a one interesting technology. This mechanism we use in big power plants or in water pumps. In water pumps, what happens? Two types of tracking mechanism we use. One is manual tracking, other one is automatic. Automatic tracking means, for example, I say sunflower. I think you all have seen the sunflower flower. So sunflower moves according to the sunlight. Wherever the sunflower faces to that. In the same way, here also the module totally moves with the sun. If the sun is on the eastern side or in the middle of the sky, it moves with the sun. And manual tracking is that we do it with manually. We change it in 3 times. One when sun rises towards east, in the afternoon flat, and when sun sets, just to increase the generation output of the module. If you fix it, yesterday we have seen that if you fix it to the latitude of the location and south facing, so when sun comes in perpendicular to that, then the generation happens. But in case of tracking, it totally tracks the sun for whole day. So generation increases by 20 to 30%. But one disadvantage I call is here that even the investment also increases. So next one is cable switch junction boxes. And as I said, the main point yesterday that even though solar water pump is a off-grid system, off-grid means use of battery is compulsory. But here in solar water pump, we don't use battery. So how then it performs? As the radiation fluctuates, the sun is intensity is now high. Maybe after two minutes again, the cloud has come. So intensity has reduced. In that case, how the pump will be on and off, then automatically pump gets damages. So for that reason, here we use DC to DC controller. We also call it as boost controller. Okay, in earlier days, we had booster on our fridge or on our TV. So when there is a fluctuation of voltage in the grid, so to save our TV and fridge and all these electric gadgets, we use maybe at least 30-40 years ago, we had boosters. So whatever be the fluctuations in the input, but output is always continuous to protect our TV and fridge. So in the same way, this is a DC to DC controller. We call that as booster. As all solar applications are DC output, so this is DC to DC. So input is DC, output is DC. So this works as a booster, especially under low light conditions. So for efficient performance, as per the standard test conditions, we need 1000 watt per meter square radiation. But if it is low, if it is 500, if it is 400, if it is 200, then what happens? Suddenly now it is 1000 watt per meter square at 12 o'clock. Suddenly at 12:10 it has come down to 200 watt per meter square because cloud has come in the middle. In that case, what happens? Then your pump will be on and off, and automatically pump gets jammed. For that reason, we use it DC to whatever with the fluctuations in the input, output will be continuous. So this is used in the low light conditions, cloudy days, early morning and late evening. The voltage output of the PV panels is often too low to run a pump, so the controller acts like a gearbox which boosts the voltage to run the pump. So if the voltage is low, if you are using the pump of 24 volt, because I'm using DC pump. For example, we consider a DC pump of 24 volt. If input is less than 20 volt, then pump will not run, or suddenly it has increased to 22 volt. So for this reason, whatever be the fluctuations in the input voltage, but output is also, it boosts to 24 and continues. So the controller can switch off the pump until sufficient power is available to meet the pump's specified minimum operating power input range. Likewise, when the PV panels produce too much power, output to the pump prevents it from running faster than its maximum rated speeds. So if it is more than 24 volt, if the pump module is supplying more than 25, it is supplying 30 volts sometimes. So it means that the pump runs faster, and that is also a disadvantage to the pump. In that case also, DC to DC controller controls this, all the fluctuations in the input, and gives output in a proper way to run the motor and protect the motor. So this is a basic description of solar pump, whether you are using centrifugal or submersible pump, whatever be the pump, but this is a basic description. This is how a solar water pump functions. So now we will see individually. What about centrifugal? What about submersible? So we will see individually and also the tracking mechanism. So first, we start with the DC solar water pump. So DC means even though the solar module's output is DC, so pump is also DC, so we don't need to use an inverter in between. So if the pump is DC and the module also DC, then it is a simple connection. You're connecting the solar array to pump controller to motor. That's it. So I'm not talking about here MPPT charge controller, because charge controller is totally a different topic here. But in summary, I can say that MPPT is it always tracks the maximum voltage in the solar module. As I said, solar modules are nature dependent, not like our conventional grid. So in conventional grid, what happens, even if you measure at morning 6 o'clock or afternoon 12 o'clock or whatever in the evening, whenever you measure in 24 hours, your grid electricity shows 230 volt. But in case of solar module, that doesn't apply. Solar is totally dependent on nature. If the temperature rises, if I say at 7 o'clock my voltage is 24 volt, but once the temperature rises, voltage falls. So at 12 o'clock in the noon, when the temperature is 50 degrees in summer, in that case, it will not give the maximum voltage. But still the charge controller, MPPT charge controller, tracks the maximum. Means it always tracks it always tries to get the maximum voltage from the solar array. So MPPT is nothing but an algorithm. It's not nothing. It's not any component. It's an algorithm in the charge controller to track the maximum voltage from the solar array and supply it to the pump. So MPPT is compulsory in every solar system, whether it is power plant or water pump. So in case of DC, we don't use inverter, it's a direct connection. Now come to the AC, so AC water pump, AC solar water pump. So as we say, it is AC. So output from solar module is DC. So we'll convert it by using the inverter. But MPPT is compulsory in every solar system. So here MPPT, DC, input to inverter is DC, output of inverter is AC, then given to the pump. So the pump here is again AC pump. As the pump is AC pump, so we are using the inverter. So why? So in some cases, what happens, some farmers may come to you and ask, see, I don't want to change the pump. Whatever the pump I'm using till now should be same, but it should run with the solar module. So in that case, as we know that the existing pump is AC. So as a farmer doesn't want to change the pump, so just connect an inverter and then to module and run the pump. So this is your AC solar water pump. So connections are same, components are same. The only additional one is your inverter is required. So now we come to the types of water pumping systems. So solar water pumping systems. So we have different requirement. In some cases, we have borehole or well deep inside. In another cases, we have surface, means water is available in the river or lake. So in that case, you cannot go for submersible because the depth of water is less. So in that case, we use surface pump. Floating pump is also available, not much used. Mostly we use in borehole and surface, but we'll have a little idea on floating pump also. So first we start with the submersible pump. So in this solar water pump, you can see the diagram here. Submersible pump is deep inside the hole. So in this, the solar water pump is located within the borehole or well. So these pumps are generally available for 100 millimeter or 4 inch and 150 millimeter 6 inch boreholes. So if it is a borehole, you should go for the submersible pump. So the solar array is typically located near the top of the borehole and the water is generally pumped to the storage tank. So the pump controller is typically located at the solar array. So the controller is located at the solar at the mounting structure. So solar module here, it is shown in the figure like standing, but it should be facing south and tilt is equal to the latitude of the location, and it should have a mounting structure to hold the module. So the pump and the controller are interconnected using the waterproof cables. So this is how a submersible pump is seen. If it is a borehole deep inside, the water is the depth of water is more than 14 meters, then we go for the submersible pump. The same case for the conventional type pumps also. Okay. So this is the example of ratings of submersible pumps available in the market. So if I'm going for DC submersible pump, they say, see, pump type is submersible. So this is an example how you should understand seeing the catalog of any company. This is 1 HP DC submersible. Means DC means you don't need an inverter here. So they have 1 HP, 2 HP, 3 HP and 5 HP. So 1 HP is 746 watt. So 2 HP means 746 into 2. You have to calculate it. So this is a DC. So PV size requirement is 1200 watt peak. So to run the 1 HP pump, we need a solar array of 1200 watt peak. In the same way, if it is 2 HP, 1800, 3 HP, 3000, and 5 HP, 4800. So pump capacity is 1, 2, 3, and 5. So the more important thing is how many liters per day it provides. So 1 HP pump provides 42,000 liters per day. So if the installation is 7.15 kilo, this is a standard value. Not applicable for whole India. So the insolation, yesterday we have seen the India map, the radiation is high in some locations and low in some locations. If I use the same pump in the northeastern part where the radiation is low, so that 1 HP pump can give 30,000 liters per day. So this is for ideal condition. 7.15 kilowatt per meter square is for the ideal condition. That is the highest solar intensity. But it can be low also. In that case, the liters per day is low. So LPD means liters per day. So in the same way, 2 HP provides 63,000 liters, 3 HP provides 63,000, again 5 HP provides 1,800,000 liters. This is the ideal condition. If the radiation changes, it can go down, or if the radiation increases, it can go up. As if we install in Jaisalmer. So the highest radiation in India is Jaisalmer. So in that case, instead of 42,000, it can give 50,000 also. So totally it depends on the radiation. So whatever the company's catalog shows, that is the ideal condition. That's why they mentioned here 7.15 kilowatt hour per meter square. Next one is AC submersible pumps. This is DC. So in case of AC, you will be using the inverter here. Submersible, but AC. In this case, the same array size is 1200, but you can see here it is 38,400 liters per day. So this is how we calculate for this. So this is a catalog of one company which is providing. In that way, we have many companies. So yesterday we had discussed the number of companies available in India. So first you should know whether you are going for DC pump or AC pump. So accordingly, you will go for the selection of the pump. So this is your surface pump. Surface pump means where you want the water from the lakes and rivers. Means water depth level is not means less than 14 meters. So in that case, we call it as lakes, and this is called surface pump. Means open water source. So it is used on shallow wells, also lakes, rivers, and any open water source that is near or on the surface. The solar water pump is located above the water level, and the suction pipe is used to draw the water from the water. Suction pipe means this is the pipe which sucks the water from the river and gives it to the storage tank. So depending on the water level, which pump will go where, that should be decided by the installer who is installing. The design engineer or installer will think about that. In case of surface also, we have DC surface pumps, AC surface pumps, same way. So here again, array size is 900. So it is 90,000 because not much pressure is required because it is in the shallow area. So even 1800 watt peak module gives 1,80,000, and 2700 watt peak module gives 1,35,000 liters per day. So this is DC. In case of AC also, more or less same, but inverter is included in the AC pumps. Next comes to the floating pump. So floating pump is if the water source is large dam or large open well, then a floating pump may be instruments in the dams. In this system, the water pump component is mounted within a floating device, such as pump inlet is located within the water source. So here the pump is floating. These systems remove any requirement of suction pipe, and the problems can be associated with them through a floating pump. Does usually require flexible outlet pipe due to changes in the level of water over time. So in the dam, the water may be sometimes in the particular area, and after some in this according to the season, again the water can go down. So accordingly, it should adjust. So I have seen the submersible and surface pumps. I'm yet to see the floating pumps, but it's there, so we have to know the technology. So designing and selection of a solar. Now you know the general how it functions. Now next, what are the types of pumps available? Now we'll see before installing the solar water pump, what are the requirements. So first one is site visit. Of course, you should go to the site and check. Even in case of big power plants
Yes.
also, we go to the,
Hello.
yes. Anybody want to say anything here?
No problem, madam. We continue. Yeah.
Okay,
Yeah.
thank you. So first, before installing, we have to go for the site visit where it is installed. So in the site, first you should know, select the appropriate solar water pumping system to be installed. So as per the depth of water level, you should properly select the solar water pump, whether you should go for submersible or surface water pump. Next one is determine the daily and weekly requirement. So what is the requirement of that area? Suppose if the farmer will help you in this, that my requirement is this. So my requirement for daily is this, means LPD, this much water is required for daily. So weekly this is required. So monthly, how much is my requirement of water? So in case of electric systems, we design the solar power plant depending on the how many, what is the load. Means if I design a solar power plant at your home, I will first ask you how many fans you run, how many lights you run, how many hours you want to run, what is your hours for your TV and all these things. So this is how we ask for the electrical power plant. But in case of your water pump, here the load is your water. So as per the requirement of water, we design the solar power water pump. So third one is determine the location of the solar array. So where you will install the solar array. Always we need the shadow free area. So if it is shadowed, it has a major disadvantage. So you have to check the shadow free area. So the location of the the moment of the art changes as per the season. In that case, winter the sun is different, again the summer sun is different. So in that case, using the equipment pathfinder, you can check the this thing art. uh, you had to calculate using the softwares. We calculate using the winter solstice. So winter solstice of that location. So if sometimes it comes under 21st December or 21st or 22nd December, like that. So as per that, we calculate whether which, if a tree is grown, so whether that shadow is falling on the solar array or not. So these are the most important. If the shadow falls on the solar module, then the generation stops. If total shadow falls, then then the total generation stops. But if the shadow falls on half of the module, then some module damages permanently. So in this case, what happens? You cannot repair it. So in case of solar modules, there is no question of repairing and using it. Once it damages, you should just throw it. You cannot take the solar cells out and make another solar module. No, that is not possible here. So next one is determine the location of the water pump. So where you will install the water pump. Next, determine the length of cables required between solar array, pump controller and water pump. Determine where the pumped water will be stored. So how far the storage is present, that is also important. Measure the total distance from the water source to the final location of the water. So these are the points which you had to check in the site visit. So after that, one by one, we discuss how. First one is the type of the solar water pumping. So first point is appropriate select of solar water pumping to be installed. So you will find out seeing the depth of the water, whether you go for submersible pump, surface pump or floating pump. If you are going for borehole or deep well, then you are going for the submersible. If it is lake or river, then you are going for the surface pump. Next comes, as I said, the requirement, weekly requirement or daily requirement of water. So you had to make the table like this. So you had to find out the liters per day requirement from the person who actually utilizes this system, whether it is home or the farmer. So what is the requirement in January, February, March, April? So total requirement for the whole year. So the amount of water required each day or week will depend on the actual application. So in some cases, in some months, he may need less. Maybe in rainy season, he may need less water because natural water is available in that season. So as per the requirement, if the water is being used within a village or household, then data should be available and the amount of water required per person in the village or so not always only farmer uses. If a village requires water, so how many people are present in that village and per person how much water is required per day. So we calculate in that way, different way. So we should know where the water is required and what is the quantity of water required for before the calculation, before selecting the pump. Next comes determine the location of solar array. So the solar array should be located as close as to the solar water pump. However, it should be located where it is not shaded to the hours of 8 a.m. to 4 p.m. So it should be in the shadow-free area from 8 a.m. to 4 p.m. because that is the maximum sunlight available in that particular period. After 4 p.m., you can expect slowly the sun goes down and the radiation level falls and the water pumping is also reduced. But in between this period, we should always choose a shadow-free area. So solar array is typically provided with ground mounted stationary frames or frames that track the sun. So as we discussed, either you go for stationary frames means fixed for whole life or you go for the tracking system. So stationary frames means here two particular things. First one is south facing and the tilt is equal to the latitude of the location. If it is tracking, so there is no question of fixing the tilt. You cannot fix and no south facing because it moves with the sun. So tracking is done like daily sun tracking. You can do it automatically or you can do it manually. Automatically means as usually tracks the sun and moves with the sun. In case of manual, you as a person has to change the solar module 3 times. Like in the morning, face the modules towards east, in the midday horizontal, in the afternoon, face the modules towards the west. This is manual tracking. So in most of the cases in agriculture, the farmer himself changes the position manually 3 times. Or sometimes you find the fixed. Tracking is seen less because as I said, the investment cost is high for the tracking. And we don't encourage much of the tracking because it's a huge weight. The mounting structure is holding the huge weight of the solar modules. One mounting structure holds more than 1200 watt peak. 1200 watt means each module is 300 or 4 pieces. In that case, if you allow the mounting structure to move for every day, then there is a chance of breakage and collapse of the total structure. So if you're going for the tracking system, better to use one mounting structure, one module. Then the weight is less. But if you're using many modules and you're asking for the tracking, then there are chances of breakage. So better go for fixed system if the radiation is better. So we can go for seasonal tracking also. Like in summer position, you can go for latitude -15, in winter position, latitude +15 because of the position of the sun. In summer position, latitude -15, if my latitude of the location is 18 degree, so 18 -15, so position is 3 degree. In winter position, 18 + 15 degree, so the position is, okay, then in that case, the position is 33 degree. So in like this also it can be. So why we need this position? Because always we need the maximum radiation to fall on the solar module so that the generation increases. The more radiation falls on the solar module, the more generation happens. So for all these reasons, we go for seasonal tracking, daily tracking, or facing towards south, and all these things are followed further. So in case of thunderstorm, so as the solar modules are installed in the open field, so there is a chance of thunderstorm or dust storm, or sometimes we had in Kolkata Amphan recently in the month of May, and everything damaged. So in that case, what happens? The solar modules are installed and open area are in the roof. There is a chances of breakage and some modules are flown out of the field. So in that case, you have to make the angle 0, flat position, totally in the flat position. You have to keep the solar modules totally in the 0 degrees. So that there will be no wind loading. A mounting structure can hold the wind speed of 150 kilometer per hour. So the structure is made like that, but above that, then the damage happens. So the array should be moved slowly when changing the position. So during the thunderstorm or in any natural disaster, you have to go for the 0 position. You have to keep the solar module in the 0 position, flat, to the means horizontal to the ground. So next one is just next one is determine the location of the water pump. So where you will install the pump. So the type of water pump is based on the water resource, which helps determine the preferred location of the water pump. Determine the length of the cables. So cables are required to connect the solar array to the pump controller and the pump controller to the motor. So solar array to the pump controller and pump controller to the pump motor. The correct size cables are selected to avoid the voltage drops. So selection of cables depends on their ampere. So that is totally again different calculation. So we are not including this because that takes one more class for this. So just remember correct size. If you have the idea, then you can go ahead with that calculation. So correct size cables are required. We design the cables as per the voltage drop and the current flow in the cables. So determine where the water will be stored. Now the water is pumped, then where it is stored. So the advantage of a storage tank is that it can be used to store excess water under days when the irradiance is greater than the value used in selecting the solar water pumping system. So if your output is your water. If the output is high than your consumption, then you can store that extra water in any storage tank. Basically, the storage tank is an energy storage system, much like battery, like we use in PV system, electric systems. We store the excess energy in the battery. For latter part of the use, here we use a tank. This excess water can then be available on the cloudy days or nights. So measure the distance between the water source and the location where the water is pumped. So the distance is required for determining the length of water pipe required to move the water from the source to the storage tank. Next comes the solar irradiation. This is what one should understand when dealing with the solar energy. So you can check in the figure. So when I install a solar module, whether it is solar water pump or any solar PV system or power plant, when I install a solar module in the field or on the roof of my home, so when the sun rises at the 6 in the morning, it doesn't mean my solar module starts generating at 6 o'clock in the morning. Okay, and when the sun sets at 6 o'clock or 7 o'clock in the evening, it doesn't mean that my module is generating till that time. So sun rises at 6 and sets at 6. So it doesn't mean that in 12 hours my module is generating. No, it is not like that. So we call it as peak sunshine hours. We use when calculating the solar module capacity for any application, we use peak sunshine hours. Sunshine hours is different from peak sunshine hours. Sunshine hours, what you see in the newspapers in the left side, that today sun rises at this time and sun sets at this time. But that timing is not applicable for any solar application. So peak sunshine hours is what required. It shows that when the power plant or when the module starts generating electricity. Here in the figure, you can see the peak sunshine hours is from 9 o'clock to 4 o'clock in a day in the month of July. Like that month wise it is available. So 9 to 4 means your solar module starts generating at 9 a.m. in the morning and stops generating after 4 p.m. So while calculating the capacity of the solar module for solar water pump or solar uh, power plant or any solar application, not thermal. I'm not talking about thermal. I'm talking about only electricity. So you should take into consideration of peak sunshine hours. Your IMD, Indian Meteorological Department, gives you the sunshine hours, not peak sunshine hours. So as a solar engineer, we take into account the PSH. We call it as PSH while calculating the capacity of the power plant or the module array for the solar water pump. So this solar data obtained from ground mounted instruments. We use pyronometers, mounted instruments means pyronometers. Now in more sophisticated way, we use the NASA or NREL or Meteonom satellites for calculating this, that have collected at least 3 to 5 years for estimating the solar energy. Such data may be available with any local sources like National Meteorological or Agriculture Department. So sunshine hours are available with this, but peak sunshine hours, we use a formula for calculating this. So shading of solar array, as I said, the array should be located in shadow-free location. So next is selecting the water pipe. So water pipes can be supplied as metal pipes or PVC pipes or polyethylene pipes. So polyethylene pipes mostly used because you can the pipes are flexible here. You can bend it and use it. So they are flexible here. So that's it for here. If you have any queries, you can ask me.
Yeah. Yeah, participants are request they can ask their questions. Yeah, they can also put their questions in chat box also, no problem. Yes. Okay, ma'am. I have a very simple basic question. As you narrated, surface, submersible, and floating. Uh, what we can say that these are the pipes. Is there any, yeah, pumps particularly. In this case, for floating, there is no mention, you have not explained how that technology is, because for that case, require a length of wire, conducting wire, how that one is, cable particularly we can say.
Yeah.
How that function is, how that type of, we know the surface and submersible, there is no problem. For this one is a movable case. Yeah. Yeah. How that functioning?
It functions in the same way, but as I said, that mostly we use submersible and surface pumps.
Yeah. Both frequently. Yeah.
Most of the cases we use this thing, but floating pump is not much used. As I said, that I haven't seen how it is used.
Because
But
I heard this one first time and eager to know how that functioning is.
Yeah. Actually, even the companies who sell the water pumps, they also don't mention about the floating pumps.
Okay.
But
Yeah.
this system is also available, may not be in India, but in some other parts of the world. But it's not actually used. In lakes, mostly we use surface pumps only.
Okay, ma'am. And for particular this, when we have to decided to install this solar for all type of these farms, then is there any government subsidy for farmers? Because my question is direct to this project is related to direct application to irrigation for the farmers. Yeah.
Yeah, pardon me for this
And
because I'm not the right person because I'm mostly of related to technology. In that case, sir is better. Dr. Chattopadhyay will answer all your questions regarding the government policies and subsidies. Okay, so
okay, okay.
he will take the next 1 hour.
Yeah,
In that
yeah.
case, you can ask him the subsidies and all these things because I'm not that much aware of this. Because in our institute, the things are divided. The policies and all these things are taken care by Dr. Chattopadhyay, and the
Okay,
technology.
surely I will ask him.
Yeah,
And I thank you, ma'am, for on the behalf of all participants. You have delivered very excellent lecture
yeah,
in listed language.
yeah.
Thank you, and I have a great day. Yeah,
Yeah. Thank you very much.
yeah, yeah. 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 Where is uh, after to this? So I request next resource person of uh, our 2 days online workshop, Dr. Chattopadhyay. Uh, he will be discuss uh, on the topic solar energy for agriculture, government's policy. Uh, Today he will be enlighten us on the particular topic, government policy, which policies are uh, given by our government of India, particularly for our farmers. Uh, so I request sir to continue to deliver his talk on government policy related to agriculture, particularly on the application of solar energy. Yes, sir. Welcome, sir.
Yeah, thank you very much, Dr. Lone.
Yeah.
I sincerely thanking the college, the principal of the college, and the other participants for giving us the opportunity to talk to you again today.
Yeah, yeah. Yes.
Basically, our today's focus on the agriculture. Yesterday, we talked about the irrigation as much as possible in 2 hours. Today, we will be focusing on agriculture, as we had discussed on yesterday that if the irrigation is the basic, then the result is the agriculture. So we will discuss about the agriculture scenario and then about the policies of government of India and other state governments, how much subsidy is there or the other helps are there from the side of the government in order to promote the solar pumps across the country, not in only in West Bengal or Maharashtra, but in other states also. So I all know that the largest industrial sector in India, even though we cannot say that agriculture is industry, but this is also an industry because many industries are run in India with the support, active and direct support of agriculture, like food processing industry and the other things which we consume or eat, they all come due to our agricultural activity. So agriculture plays a vital role in India's economy. 54.6 of the population is engaged in agriculture and allied activity. This is as per the census of 2011. If everything is well, then we will be having another census in 21 and 22. By that time, I am sure that the number will increase because day by day, this is not the fact that the number of people are coming out from agriculture or they are not putting their energy and intelligence for the growth of agriculture. Rather, people directly or indirectly are becoming more dependent on the agricultural sector. Whatever we get, that is the result of agriculture. So we have to understand that, and we have to respect that we have to respect the people who are directly or indirectly involved in the agricultural activity, because it contributes 17.4 to the country's GDP in the year 2016-17. And as I said yesterday, it is 19.6 or 7% to the country's GDP in the year 2019-20. And I'm sure that in 2021, if we get a good monsoon, probably we'll be getting a very good monsoon. So the GDP will touch, means the agriculture's contribution to the GDP will touch 20% like the year 2003-4. Currently, over 30 million agricultural pumps are installed in India. So now I am going to tell you, Madam has very nicely told you about the technical features of a solar pump. But until and unless a farmer is convinced to purchase that or to use that, all the technical features more or less become useless if people are not convinced. You do not need to convince people to purchase a modern tablet or modern mobile phone, because they know how to use that. And they know the advantage or disadvantage. The disadvantage they don't care. Mostly they are now focused on the advantages of the smartphone. But in case of agriculture, there is a problem. The problem is that the presence of conventional pump. Since the presence of conventional pump helping the farmers to cultivate for last many years, so they have questions in their mind that how good this solar pump would be for them for the cultivation purpose. So we need to convince them. I will try to tell you that how to convince them, what sort of data to be given to them, what sort of logic should be given to them, and they understand. Then they understand it is definitely better to go with the solar pump, which will help them for next 25 years from the day they install that, next 25 years, which they never get from a conventional pump. So I repeat, currently over 30 million agricultural pumps are installed in India. Of these, 10 million pumps are diesel based, consuming 12% of India's total diesel consumption. We should remember that India does not produce diesel. We do not have the production of diesel on our own. So the first problem is we have to import the diesel. That is the first thing. Second, after the operation, means after we use the diesel to run the pumps, the number is 10 million. So what is the outcome? The outcome is smoke. Agricultural fields will always be located more or less nearby the forest area or semi-forest area or in the jungles area, where a lot of trees and plants will be there. I would like to add here that the oxygen that we get from the 7 trees is consumed by one adult individual, human being. So if the smoke that comes out from the diesel pump, they are damaging. When 10 million pumps in India are run by the diesel. So if the trees and plants get damaged because of the smoke that comes out from the conventional pump, then you can understand that there is a threat for human life also. And over 20 million grid-connected agriculture water pump installed in the country consume 18.1% of total electricity. So the electricity which we get mostly from the conventional power sector. So from that total electricity, 18.1%, this is the data of financial year 17-18 of Central Electricity Authority, so is going to run 20 million conventional grid connected agricultural water. And for that, you need to burn 85 million tons of coal annually. So you have understood who are the villain here. Yesterday I said I am interacting with a college of Maharashtra, and Maharashtra is famous for many things. And for me, the special, I am also from Bengal. So there is a connection between Maharashtra and Bengal with the movies and theaters. So people from Kolkata went to Maharashtra to get their fortune in the Mumbai film industry from 1920, 2030s. So when you will be interacting with any Bengali, they will give the reference of movie that is very obvious. So you have understood who are the villain here. The villain is diesel, the villain is coal, which are definitely contributing to run the conventional agricultural water pumps, but damaging the environment severely. Estimation of distribution of energy sources for groundwater withdrawal in India. So you can get some data from here, state-wise, which state is using the conventional grid-connected electric pump, diesel pump, in some cases windmill, solar pumps, and manually also they lift the water, and with the help of horse or cattle like that. So that figure you will get from this graph. It is found that the electric pumps cover about 70% of total available pumping energy sources in India. As exception in the Gangetic Plain, which is dominated by the presence of diesel pump. I can tell the Gangetic Plains means from Uttar Pradesh to the West Bengal. This is the Gangetic Plain area. If you come, especially, I will not say the total Uttar Pradesh. If you come to the eastern part of Uttar Pradesh, then you enter in the Bihar, and then you come to the West Bengal, you can say the maximum number of diesel pumps over there. I don't know, maybe because of the availability or poor distribution system of the conventional electricity into the grid. Maybe that would be the reason. Because both Uttar Pradesh and Bihar, they do not have much reputation in terms of provided electricity to the household only. For the industry and also for the agriculture, they won't be able to provide the electricity. That's why the farmers, they are mostly dependent on the diesel pumps. Since 1970, agriculture in many states has been receiving electricity with low tariff, definitely. Because as respected Professor M.S. Swaminathan had told me that agriculture is politics in India. Definitely not today. It is from the time of independence. So you have to provide the electricity to the farmer at a low cost or no cost. In some cases, electricity is supplied absolutely freely to them. Much of this supply is unmetered. You do not know how much electricity you are giving to one individual or a group of cooperative or a group of farmers like that. Subsidized supply has played a key role in the growth of groundwater irrigation and agricultural production in the country during the Green Revolution and after. The Green Revolution was possible because of the policy that government had started to supply free electricity to the farmers so that they can lift the water from the ground and use the water for the electricity. It was needed on that time because after partition, many refugees came from present Bangladesh and Pakistan. So government had the compulsion to provide food to them. For that, the production of the crop, or there was a pressure onto the government to make the double or triple production of the crop to save the country from the devastated famine. For that, the government of India correctly on that time had decided to provide the electricity mostly freely to the farmers to grow the crops. I have tried to give some kind of table here also, that which utility is giving at what price, which utility is giving at what price. They are giving the electricity to the farmer. This is the scenario, means this is the background. But there are challenges, time is changed now. So sitting on 2021 are almost 3 months are over. After 9 months, we will be entering into 2022. We cannot expect the things to happen at this has happened in 1960s, 1970s, 1980s, or 1990s like that. We were completely dependent on letter to communicate to people. Now I am giving you the speech sitting at Hyderabad, Telangana, and you are listening to that, and you are directly putting that into the YouTube so that the whole world, whoever is interested and connected to your esteemed college, they can listen our lecture, our demonstration. So time is changed. We cannot just grab or hold the policy which we had formulated in late 50s and continue with that with 2021 or 2022. So that policy or that technology has become a burden for the DISCOM, means the distribution company. As I told yesterday, distribution companies means in Kolkata it is CESC or the West Bengal State Electricity Board. In Mumbai it is Tata Power or the Maharashtra State Electricity Board, or the Reliance Power is also there, and the other companies are also there, which are providing electricity to the people against money, definitely. And also each and every state government, they have a company which distributes power, mostly not in the city. In some cases, Hyderabad city, do not have any private player over here. So the government only distributes the electricity. These type of companies are called electricity distribution company or DISCOM. So have been reeling under massive financial losses for a long time due to subsidized electricity supply to agriculture. Today, every company, means private limited or limited company, as per the rule of Government of India, they have to submit their annual return. In the annual report only, they can put their annual taxation return, and that has to be uploaded in the website. So nothing is hidden nowadays. So if you want to see my last year's income, so you can open the website of Chandradeep Solar Research Institute and you can see the balance sheet over there. Every company, each and every company, small, big, large, medium, they have to upload their website with the fact and figure of their financial health. So if you check the financial, you can go to the Google and write the electricity distribution companies of India. You can write private and also the government, state government. Electricity is a state business. Central government can formulate the policy, but a central government cannot say to the particular state government that you have to do that. It is like law and order. Until and unless there is a terrorist or national disaster activity, the central government directly cannot interfere with the law and order to any state government. They can advise like that. For the electricity sector also, they can advise to the state government, but they cannot dictate the state government. So you can write the private DISCOM companies India, you can write state government DISCOM companies in India. You can get the website of them and you can go to their accounts section of the annual report and you can see the balance sheet. What you will see mostly, that electricity distribution companies have been reeling under massive financial losses for a long time due to subsidized electricity supply to agriculture. This is a problem, definitely. It is not that only the agriculture sector is getting the subsidized electricity. Household is also getting. But as I said, agriculture is a politics. So it is always mentioned that agriculture sector is getting a subsidized electricity. This subsidy is covered either by consumers of the categories who are charged higher tariff. Means there are some sector where they are charged more to pay, or by grants from the state government, direct subsidy. So as I can tell in West Bengal, for the case of West Bengal, the farmers, most of the cases they pay rupees 1.50 per unit, and state government directly subsidize the West Bengal state government electricity development company. So like that, every state has their policy either to charge the person who can pay more, or directly they give the grant as subsidy to the state government discom. Therefore, free or subsidized electricity supply is seen as the primary cause of unsustainable groundwater extraction, as well as the poor quality of electricity supplied to rural consumers. We have to understand one thing. Is it really serving the purpose of anyone? In one way, you are trying to make happy everybody, and you cannot make happy everybody. And you are making angry everybody by trying to make everybody happy. How? That you are unable, it's a visual cycle. In economics, we have learned in the school, college that visual cycle of poverty. Why a person is poor? Because he is a poor. Like that, sorry, like that, why I cannot supply a good quality of electricity? Because I don't get any money. As I don't get any money, I cannot give the good quality of electricity. Since I cannot give the good quality of electricity, I give the poor quality of electricity, they cannot use that properly, and they remain poor for many years. The rural consumers, they remain poor. Since they are poor, they cannot pay the price. So you have understood that it is a visual cycle, and somebody has to cut this cycle and have to make free everybody. And if you cut any part of your body, then the bleeding will come, but afterward, the natural healing will be there. So the government of India has decided to think in a little bit different way. Farmers and discoms have been caught in a low equilibrium because of low revenue from agriculture for discoms and poor supply quality for farmers. It is a challenge to ensure quality supply and service to rural consumer thinly spread over a large area. One way suggested to break out of this low equilibrium is to raise agricultural tariff. So I said that one has to cut. So how to cut? Cutting is not possible in a democratic country like India. As I said, 54% of the Indian population are directly or indirectly involved in the agricultural business. And they have become habituated to get the electricity either with low cost or with no cost. So suddenly if you tell them that from tomorrow or next month, you have to, or after 3 months, you have to pay 10 rupees per unit, they will not, obviously, they will not vote for you. So it is a great challenge for any political party to take such a hard decision. So to break out of this low equilibrium is to raise agricultural tariff, which will improve the discom's ability to provide better quality supply. However, improvement in power and service quality through higher tariff is uncertain. Again, the question is, even if government puts that burden onto the farmer or the people who are involved in the agricultural business, even though they start paying, they say, okay, we are ready to pay, but give us good quality electricity, will be possible, whether that will be possible for the discoms or not. So let me see. what the experts are telling. However, improvement in power and service quality through higher tariff is uncertain, largely owing to the lack of accountability of the DISCOM in ensuring improvement in supply and service quality. Then the DISCOM will say, okay, I am getting rupees 10 per unit, but I have the debt for last 25 years. Let me pay the debt first. Then I will think of improving the quality of the supply, electricity supply. Then the problem remains same. So initially today in my talk, I have identified the villain. Then I am trying to understand how to remove this villain. One way, just give a punch at his face. Normally in the Bollywood movie in 60s, 70s, 80s, we have seen the hero used to come and give a punch to the villain and villain used to run. So in this case, I just remove the poor quality supply and I put a huge burden, means a normal burden or huge burden, whatever you say. I stop giving subsidy, either the cross subsidy or the direct subsidy, and tell you that you become self-reliant, self-sufficient, and start paying properly on time. I create a model also for that. Nowadays the term business model is very popular term. That for each and everything people ask, what is your business model? So, I improve my business model and I approach to the stakeholder of the agricultural business that you start paying from. Then after 3 months, I give you the 3 months niche time and they also get ready. But the question is that whether the DISCOM will give a guarantee to improve the supply and service of electricity. I am telling you, they won't be, even though they want anyone, Reliance, Tata, CSC, or any other company, private company, even the government DISCOMs, the West Bengal State Electricity Board or any other state electricity board, they have to pay the huge debt that which they have in the market. The moment huge money comes in their account, the people, the company which they had given the debt to them will not spare to them anymore. They will say, you have the money now, first you pay my money back, then you try to improve or you improve the quality supply. And in order to improve the quality supply, huge investment is required. So the dishum type, approach the Bollywood hero used to offer in 1670s, 70s, 80s, 90s, that is not possible anymore. You have to adopt a different plan. And in this case, there is a risk also. What is that risk? Surveys show that farmers receive fewer than scheduled hours of supply, which are often erratic to them. See, they are now not in a position to pay, so they do not get also the electricity properly. So, if the DISCOM has promised to give them the proper supply, say from morning 10 o'clock to or 9 o'clock to afternoon 4 o'clock like that, they do not get the proper supply during that period of time. It is very erratic for them. And with frequent interruption and voltage fluctuation, causing farmers to incur avoidable expenditure on pump repair due to motor burnout. So Dr. Lone is from physics background. He is very much aware of the functioning of electrical machineries. So he knows if the voltage fluctuation is there, then there will be an obvious damage in the mechanical devices. And who will repair that mechanical device? The farmer. And that will be very, very much painful to them because every component or the devices are very costly. Transformer burn out are a common occurrence, and there are a long delay in getting the transformers repaired because they don't pay or pay very less money. So the DISCOM do not listen to them promptly as they listen to us. It had happened during the time of Amphan in Kolkata. The whole city, became just like a dustbin or a garbage box because of the 120 km per hour to 210 km per hour wind speed. But CESC has done extraordinarily good job to get almost everything ready in 7 days. Now we have WhatsApp, phone, television, so we accused them, we criticized them, we even harassed the CSC staffs here and there, but they responded to our call and they did as much as possible for them to do, and they repaired each and every damaged parts in 10 days. Because we pay the electricity bill on time and we do not raise any question about the tariff charge. Since we pay, we have the right to ask them to do our work. But in case of farmer, I have already taken 25 minutes to describe their sorry situation, sad situation. Then there is a safety issue also. Safety of farmers is also an important issue. Irrigating fields during the night can be risky and hazardous, especially for women and old farmers. There is so not only because of the danger due to the creatures like snakes, but also electric shock accidents. In the darkness, there could be some kind of, any wire or any live wire or electrical line can be exposed to the nature, and anybody, the passers-by, if they overlook that because of the darkness, there could be human loss or the important animal loss for the farmers or families. Accidents during pump set operation while coming into contact with low-hanging conductor and while attempting to repair failed transformers are common. As per the data provided by the National Crime Record Bureau, NCRB, the number of deaths due to electricity accidents was nearly 10,000 in 2015. That is not a very small number. 10,000 people had expired due to electricity accidents in the year 2015, mostly occurring in rural area, definitely, because darkness is there in the rural area. And this number has been increasing every year by 5 to 6% in last 2 decades. That is also a government data, National Crime Record Bureau, NCRB 2016. So you have understood, I have understood the major risks that the farmer is interacting every day just for their livelihood and for our survival reason also. Then there is a CO2 emission issue. I told you in the beginning only that if you use the diesel, 12% diesel is used by the farmers, 10 million tons. So the CO2, billions of liters of groundwater pumped out every day, contributes to carbon emission in 2 ways. Emission released due to the pumps used for extracting water, and carbon dioxide released due to biocarbonate extraction. That is damaging the nearby green areas. The estimates are based on data from the Central Groundwater Board, that is CGWB, and GRACE, Gravity Recovery and Climate Experiment Satellite Mission of NASA. And the total carbon emission from the groundwater sector have been estimated to be between 32 to 131 million ton a year. 32 to 131 million tons a year. And the carbon dioxide emission due to biocarbonate is about 0.72 million ton per year. Total 2 to 7% of the total annual carbon dioxide emission from India. We used to know that the heavy industry or the big industry, large industry that are relating that are working or dealing with the iron, steel, mines, they only create the issues. They are only involved with the issues of climate change and the CO2 emission and the other GHG greenhouse gas emissions. But even though not directly, but indirectly, agricultural sector also contributing 2 to 7% of the annual carbon dioxide emission of India because of using either diesel operated pump or conventional grid connected electrical pumps. So as I said, now the green picture comes. As I said, the villain has been identified. We cannot throw them, like the popular hero of 60s, 70s anymore. We have to replace them with intelligence by using a different, eco-friendly, soft, cost-effective device. And that is solar pump. And that initiative has been taken by the government of India with the support of all state governments. In 2020, the union budget has laid a major emphasis on use of solar energy for farming under the ambition Pradhan Mantri Kishan Urja Suraksha Evam Utthan Mahavidyalaya Yojana. That is called a PM-KUSUM, in short, KUSUM scheme, with the Finance Minister Nirmala Sitharaman extending the scheme's implementation with new target. She said, I quote, I propose to extend the scheme to allow 20 lakh farmers to set up standalone, Madam told yesterday what is standalone solar pump, standalone solar pumps. Also 15 lakh farmers will be helped to solarize their grid-connected agricultural pumps. In addition, the scheme will allow farmers to set up grid-connected solar power generation capacity on fallow and barren land. Mrs. Sitharaman, Finance Minister of India, said in her budget speech in Parliament. So this is the answer, to our decade and decade-long pain that our Indian farmers have undertaken. That to allow 20 lakh farmers to set up standalone solar pump. How to allow? To subsidize by making subsidize almost 100% in some cases the standalone solar pump to the farmers. Also 15 lakh farmers will be helped to solarize their grid connected agricultural pump who already have the grid connected agricultural pump that will be solarized by removing the conventional grid connection. So this is the answer. In addition to that, the PM KUSUM scheme was launched by the Ministry of New and Renewable Energy, MNRE. Yesterday I said the parent body of all renewable energy related activity within the periphery of Union of India, Government of India, to support installation of grid solar pump in rural area and reduce dependence on grid in grid connected areas. So, in addition to that, the Cabinet Committee of Economic Affairs, CCEA, had in February 2019 approved the launch of the scheme with the objective of providing financial and water security. Yesterday we had discussed about the energy security, so we had the issue of water security. That was also raised by Dr. APJ Abdul Kalam when he was the President of India. So not only with the energy security by giving them the solar pumps, but also the water security. With the overall goal of making the farmers independent, the implementation guideline for PM KUSUM scheme were announced in July 2019. It entails setting up of 25,750 megawatt solar capacity by 2022 with a central financial support of rupees 34,422 crore. Today, Dr. Lone was asking about the government's financial support. I think I have some data for him. And I'm directly coming to his question. According to the latest notification by MNRE, 30% to 90% subsidy on benchmark capital cost is available for all consumers. As I said, electricity is a state subject and agricultural policy is also a state subject. So except railway and some other things, central government cannot directly jump onto the periphery of any state government and put their wishes onto the shoulder of state government. They can advise. So the slab is given, but state government concern has to take the call that how much subsidy they provide to the farmer. So 30% to 90% subsidy on benchmark capital cost is available for all consumers. Now the obvious question is how much a particular farmer will be getting. That answer can be given by the designated nodal agency of that particular state government. As I said, in case of West Bengal, it is WebREDA. In case of Maharashtra, it is MEDA. In case of Jharkhand, it is JEREDA. In case of Odisha, it is OREDA. In case of Tamil Nadu, it is TEDA. So a farmer should contact to even by email or by downloading the app. It is possible for the farmers to pay nowadays, because whether we eat or don't eat, we all have the smartphone. From 5 years to 95 years, alive Indian citizen are having smartphone, whether we have the food or medicine. And you all know that how to download the app. And this is an important app. You download the Kusum app and you will get the answer that how much support I might get from the designated state government and subsequently from the central government, and what is the procedure to run my agricultural activity by availing a solar pump. So 90% on solar water pumping system for farmer only. So you will get 90% subsidy if that pump is used by the farmers. Then, as we know, the 30% subsidy is given for the solar water heater also, which we use to make the water hot during winter, or in the hospital, schools or colleges, we can install a solar water heater and can save our power bill and also save the global warming. But it is not for that. More than 30% you will not get for the solar water heater. But 90% you might get up to. It is not that 90% only. No, it is up to 9%. Some medical shops, they write the up to 25% discount in front of their shops. So up to means if you would like to buy a strip of Calpol 650 or Crocin paracetamol 650, you might get 10% discount. And if you are willing to buy some medicine of high blood pressure or sugar, you might get up to 20%. So it is not exactly 90%. Up to 9% subsidy you might get if you are involved in agricultural activity. 70% for 3 hill states like Himachal, Uttarakhand, and Jammu Kashmir. And 30% for all states in India. It's a flat. It's a flat. But again, I will tell that we all have experienced in our life that government support schemes are variable and it changes with time. New budget has been introduced but the debate is still on and it is not passed yet. But that has been introduced in the month of February in the National Capital Parliament. So after this program, definitely you will be giving the messages which myself and Madam have been giving for last 2 days. You will be passing these messages to the farmers or the farmer associations who are involved in your area, in your areas, through the Honorable MLA and MLC, I will request the college authority to check the MNRE website about the latest announcement. But so far, till 2020 March, the announcement was like that: 30 to 90% subsidy a farmer might get to avail a solar pump under the PM Kusum scheme. So this is more or less about the government policy and the support schemes. Now I will discuss about one innovative project that we are trying to develop from last year. And I will, when I got the chance to speak to the college authorities through this interactive session, I will request them, if possible, to help us to get this project developed. This is a totally non-commercial project, and we are trying to help the farmers by understanding while working in the field and seeing their condition. We also got pain, and we also thought that if we could develop a new generation Android-based application which educates farmers about the benefits of solar water pump for the better production of crop. Because I am a over 50 person. How long I will be alive and eating all the foods? Not long time. But I have a son, and he will be having son or daughter in coming years. So food is necessary. I do not say food, quality food. Quality eco-friendly foods are necessary for all Indian citizens to have a healthy life. And if farmers are in trouble and they do not know how to handle that trouble, then okay, another 10-15 years, I do not find any problem for in a massive problem for the Indian citizen until and unless we have any natural calamity like tsunami or the Amphan like that. After that, there much disaster is waiting for the all Indian citizens. By thinking that, with the help of Madam and her team, we are trying to develop a Android-based application which will help the farmer in their language, state-wise. Obviously, in Maharashtra it is Marathi, in Tamil Nadu it is Tamil, Andhra, Telangana it will be in Telugu, in Bengal it will be in Bangla. That how to use the solar pump for the better production of crop. The app should be available in local language. Large number of mobile phone users will be available to access this application, which will increase their awareness about the schemes and supports of the national and state governments. Today, I don't know with how many farmers, means the farmer body or the farmer leader or the directly any person is there in the audience who is directly involved in the farming business or agricultural business. So, and I am also not sure that how many of them will come to know about the schemes and like that. So we are trying to develop this app to give the awareness to them about the support of the center and national government. Dependence of DISCOM will definitely reduce and use of solar pump will increase. You will be, energy wise secured. You will be a energy independent person. You will not depend on other, whether they give you a quality electricity, that there will be no fluctuation of voltage and current. Suppose I take it for the sake of argument, okay, the per unit cost has become 10 rupees, that is don't pay to the depth first, and they improve the quality supply from next 3 months onward. And but still we do not know. Even in a city like Kolkata or Mumbai, many relatives are living in Mumbai, and I frequently visit Delhi. So I have not seen a good quality of electricity supply in the evening time in summer. And summer is long in India. Whenever we on the AC, and every home is having now 2, 3, 4, 5 ACs also. So every time you on the AC in your room, you can see the fluctuation. So what will happen to the farmer who are living 100 kilometers away from the city and almost with nothing? So you can understand they will never get, and I pardon it, but they will never get the quality electricity from the discoms. So they should be energy independent, another term of Dr. APJ Abdul Kalam, and then the energy security comes to them. So dependence on discom will reduce and use of solar pump will increase. Since solar irrigation pump have higher reliability, the production of crop will increase and their income of the farmers will increase. Because there will be no fluctuation, because the water will be available even in the night time, because they have lifted sufficient amount of groundwater, and with the help of that solar module, you can put some lights surrounding in your agricultural field. So even in the evening time also you can go to the ground for the agricultural activity. So your crop production will increase and you can sell that crop in proper price and your income will also increase. Selection of the solar pump manufacturer and services providers will be easier for farmers. I have given the name of 5 companies, but that is not the only 5 companies which are working in India. We all talk about Ola, Uber. Wherever we go, we take our smartphone in our hand and search if any Ola, Uber taxi is there nearby to take me to the my point where I want to go. But I got the information there are almost 450 taxi services roaming around in the whole Indian territory. We do not know their name, but they are also very reliable. So these 5 companies are not the 5 companies only which are providing the solar pumps to the farmers or ready to supply the solar pumps in India. There could be another 15 to 20, I can tell you. I have to collect their name and I have to check their reliability also. So I did not give a long list. I have given the list of only 5 companies. But in the app, we are trying to give the name of other companies also. So I give a sincere thanks to all of you for your patience, and I am now ready to take the questions so that
Yes, sir.
I can interact with the people and can give them screen time.
Yes, sure, sir, sure. So participants are request to please ask your related questions. Yeah.
चॅट बॉक्स मध्ये आहेत सर क्वेश्चन.
Yeah. Also, you can put your questions in chat box also. There is no problem. I think. Sir, can I read this question?
Yes.
From Mishu Gupta. Sir, who gets the solar rebates? Who gets the solar rebate?
See, who gets the solar rebate means every Indian citizen, actually they are supposed to get the solar rebate. But in terms of what? Means, suppose I am running an industry, I can go to MNRE and can say that I am going to install 100 kilowatt peak solar power plant as a captive solar power plant. So I should get the
Okay, sir. Yeah. Sir. Yeah, any more questions, please? Now the session is open for discussion. Yes, sir.
We can approach to the local state, the nodal agency with our proposal. Then they can guide you about the rebate. Every Indian citizen or every Indian institution.
Okay, sir. Is there any more questions? Yeah, from Sanjay Kumar Dalvi, how much area of field will be required for installation of solar panels for 2 HP motor pumps?
Kindly repeat again, voice is not clear. I
Yeah,
couldn't.
sir, I will repeat it again. How much area of field will be
Right,
required for installation of solar panels for 2 HP motor pump?
2 HP motor pump.
Sir, only area is asked. Yeah.
I think there is a voice issue.
So the area is required for 1 kilowatt peak solar power plant is 8 meters square.
Yeah, for 2 HP.
And if you want to have a 2 HP, then what will be the 2 kilowatt? So 14 to 15 square meter.
सर तुमचा आवाज चालू करा, अनम्यूट करा.
Yeah, 14 to 15. Okay, sir. Okay. I think Dr. Sanjay Kumar is satisfied with this answer. Yeah.
Thank you.
Yes. Yeah. Welcome. Sir.
So if there are more questions, Dr. Lone, you can take them and can send to me by email.
Yeah.
I will attend since there is network issue. There is network issue.
Yes, sir. Yes, sir. You have another important work also, sir. Okay, sir. Thank you for your very excellent and informative speech. I hand over my chairs to my colleague, Mr. Sarge, sir, for vote of thanks.
Thank you, sir. I am audible, sir.
Yeah.
Yes.
Yeah.
I personally thanks to today's resource persons, Mr. Dr. Sandeep Chattopadhyay sir and Madhuchandrika Chattopadhyay madam. They give a very informative talk on solar power and irrigation. Sir, your information is definitely valuable for all the participants. Thank you, sir. I personally thank you to from our Department of Physics, Vinayakrao Patil, Mahavidyalaya, Vaijapur. Thanks to Honorable Shri Appasaheb Patil, Krishi Bhushan, Head College Development Committee, Vinayakrao Patil College, Vaijapur. Also, I thank to Honorable Satish Chavan Sir, Member Maharashtra Legislative Council and Secretary of Marathwada Shikshan Prasarak Mandal, Aurangabad. I also thanks to Honorable Shri Prakash Saunke Sir, Member Maharashtra Legislative Council and President of Marathwada Shikshan Prasarak Mandal, Aurangabad. Thanks to our respected principals, Zine Sir. Also, I thanks to Vice Principal Saunke Sir and Pardeshi Sir, and our respected HOD Lone Sir, and all the participants who have participated in this workshop. Thank you, sir. Thank you. One suggestion is there. After this session, we will provide a feedback form. Please submit it so we can generate certificate. Thank you, sir. Thank you.
Yeah. Thank you all of participants, and have a wonderful day ahead. Thank you.